Okay. So in the last class, so that I have explained about it is a radar modulator and the duplexer. Okay. So if you take the radar modulator, it is used to control the what the amplitude of the RF signal. It is entirely based on the width and the amplitude of the pulse. Okay, and if you take the duplexer, so that it is used to give the connection, it is between the antenna and the transmission. If the signal is to be transmitted, and in the same way, if the signal is to be get received, it is going to give the connection for the reception. Okay, it is about the modulator and the duplexer. Okay, and in this class we are going to study about it is radar display systems here. Okay, it is a radar, okay, display system. So in this class we are going to study that is introduction to radar display. It is what are the radar display techniques, and in this case what do you mean by the deflection modulation, and what do you mean by the intensity modulation, and also the comparison between the deflection and the intensity, and a scope display, and it is PPI scope display. Okay, all this is to be studied in this class here. Okay, so that if you take the radar display, okay, so that you can able to see it is the radar here. Okay, it is to be fitted with the antenna, and you can able to see the target here, so that it can able to measure the range here. Okay, so that all the parameters is to be, it is to be get displayed in any of the display, either in terms of the waveform signal or in terms of the numbers. Okay, suppose consider that here. So in this diagram, it is represented as it is equal to 6.2, it is microsecond. It is indicating the wavelength here. Okay, and after that you can see the one more, it is 1 nm, it is equal to 1, okay, nanometer. Okay, it is going to measure the distance in this way. So all of these parameters is to be measured on the display system. It is itself is the radar, okay, display. Either it can be the CRT tube, or it can be the LCD display, or it can be LED display, or anything. It is itself is acting as of the radar display system. So it is an electronic instrument. It is which is used for, okay, displaying the data visually, is known as the display. It can be anything. If it is going to be, okay, represent in terms of the numeric, or in terms of the symbol, or in terms of the diagrammatic, or in terms of the graphic, okay, or in terms of the, it is waveforms, it can able to see with the eyes, it is visually, it is itself is called as of, it is a display system. So the electronic instrument, it is which displays the information about the radars, okay, the target, it is visually, is known as, it is radar display. If you take only the definition of the display, it is going to display the data, and if it is going to display the data of the radar, okay, it is called as the radar display. Okay, it's very simple. If you take the modern systems is typically use the some sort of the raster scan display in order to produce a map like image. If you take the Google image, if you take the Google Earth, okay, etc., or the example of it is map like image. Okay, this is about the radar display. Understood the definition? So if any of the information is to be get displayed on the screen, either on the CRT, or on the LED, or on the LCD, which is to be visually seen, is known as the display. And if the information is about the radar's target, it is called as the radar, okay, display. And it can able to represent in terms of the numeric, so that you can able to see the numbers here, and it can also able to represent in terms of the symbolic representation, so that you can able to see the microsecond and all that, and it can also able to represent in terms of the graphical lines. Okay, so that you can able to see the target graphic, you can able to see the, it is antenna, you can able to see the target, I'm sorry, so that you can able to see the radar, etc. If it is to be represented in terms of the graphically also, or it can also be represented in terms of the waveforms. Okay, that is itself is called as, it is a radar, okay, display system. Understood? Okay, and if you take the types of the display system, it is to be mainly classified into the main two types. One is of the, it is a deflection type, and another one is of the intensity type. And it is to be measured, it is to be based on the deflection modulation, and it is to be based on the intensity modulation. Okay, so in this case, what do we mean by it as a deflection modulation? It's a technique in which the movement of the electron beam in a CRT is controlled by, it is transmitted and the echo pulses. So it is exactly same as that of your, it is CRO. Okay, cathode ray tube. Okay, so that it is going to operate with the two signals. It is one is the transmitted signal and another one is the echo signal. And apart from that one, it is also going to take the one more signal. It is the sawtooth waveform. And after that, it is based on that one, it is going to move the movement of electron, the electron beam. According to the movement of the electron beam, it can able to represent the signal on the screen. It is itself is called as the deflection modulation. Okay, so it's a technique in which the movement of the electron beam in the CRT is controlled by that, it is transmitted and the echo pulses. Echo means it is a reflected signal, and what this transmitted pulse and the echo pulse are applied to the vertical, okay, deflection plates of the CRT, and what this the sawtooth waveform are applied to the horizontal deflection plates, and what this the it is transmitted and the sawtooth are away, it is forms are to be synchronized. It is when it is no target is present, the horizontal line is to be displayed on the screen, and what the presence of the target results in the echo pulse. An example you can take as an A scope display. If you take the B scope, C scope, D scope, etc., etc., are the examples of the deflection modulation. It is exactly same as that of the CRO I said. So if the no signal so has been applied for the CRO means, so what happens? It can able to give you only a single horizontal line. Yes or no? Okay, if the CRT has been switched on, it is going to show you only a single horizontal line. It is when it is no target is present, the horizontal line is to be displayed on the screen. And if you apply the transmitted pulse and the echo pulse is to be applied for the vertical deflection plates, and what this the sawtooth is to be applied for the horizontal deflection plates. After applying the signals in this way, it can able to give you the information about the target on the display, and it is going to visible as in this way here. Any type of the waveforms like this, okay, like this, or in terms of any of the sine wave, etc., it is going to visible as in this way here. Understood? I think you know about the CRO. It is to be implemented with one is along the x-axis and another one is the y-axis. Okay, so internally it is consisting of the vertical deflection plates and the horizontal deflection plates. It is for the vertical deflection plates, the actual transmitted signal and the reflected signal is to be applied, and for the horizontal deflection plates, so that you are going to apply the sawtooth waveform. Okay, so that it can able to make the calculation internally. According to that, it is going to display the beam, the electron beam on the screen, and it is itself is going to visible as the signal. Understood? This is all about the deflection modulation. And if you take the intensity modulation, it's a technique in which the number of the electrons, okay, reaching the anode in a CRT is controller in accordance with the echo signal. So in this technique, so echo signal is applied to the control grid of the CRT, and any variation in the echo signal strength will affect the intensity of the electron beam and the illumination of the screen. It is to be based on the intensity of the light. I think you know about the intensity, increasing in the brightness, and if it is going to decrease the brightness. Okay, so according to the intensity of the light, or according to the intensity of the what electron, it is going to display the signal on the screen here. Okay, so it can able to display only for the 90 degree, or only for the 180 degree, or only for the 270 degree, or the entire 360 degree also it can able to display the target information, or else it can able to display only the certain angle, and it is whatever the remaining part, it is going to be clipped off here. Okay, according to the application you are using, and according to the display system available, it is going to display the signal in terms of the intensity. It is itself is called as an intensity modulation. Okay, in this case, important is whatever the reflected signal is there, no, it is to be applied for the control grid of the CRT. It is going to control the entire signal, and it is to be get displayed on the screen. This is about the intensity modulation. But in case of the deflection, the actual signal is to be applied for the vertical deflection plates. But in this case, the actual signal is to be applied for the control grid, the only difference. Okay, this is about the intensity modulation. And after that, if you take the differences between the deflection modulation, so an example is for the intensity modulation is, it is plane position indicator. It is PPI. Okay, and if you want an example for this one, means if you take the laser light display system. Okay, according to the structure, it can able to display it on the screen there. It is so it's nothing but it is plane position indicator. According to the position, it can able to display it on the screen, and it is going to vary the intensity according to that. Okay, this is about the intensity modulation. If you take the comparison between the deflection and the intensity, means in the deflection, it is going to display in the coordinates as xy, so that it is going to make use of the horizontal deflection plates and the vertical. For the horizontal, so that you are going to apply the sawtooth, and for the vertical you are going to apply, it is transmitted and the echo signal. So it is to be represented in the coordinates as an xy. But if you take the intensity, so it is consisting of the polar coordinates, so that you are going to apply the only one signal, and it is to be applied for, it is polar controller. Okay, and if you take the deflection, it is a rectangular display. So I think you have seen the CRO display. Okay, so if you want, means you can see there. So it's having the rectangular display CRO. But if you take the intensity modulation display, it is of the circular display. And what this radar antenna in the center of in the center of the display. In the center of the display itself, it is consisting of the antenna there. And after that, it's a technique in which the movement of the electron beam in the CRT is controlled by the transmitted and the echo pulses. Obviously, it is to be controlled by the transmitted and the echo pulses applied to the vertical, okay, deflection plates. If it's not applied, means it is going to show only the horizontal line. And in the intensity modulation, what happens? So any variation in the echo signal strength will affect the intensity of the electron beam, and according to that, it is going to change its illumination. So its brightness, it is going to change. And in this case, in the deflection, if you take the transmitted pulse and the echo pulses are applied to the vertical deflection plates of the CRT, and if you take the what so sort of waveform are applied to the horizontal deflection plates. But in this case, it is two pair of the coils on the opposite sides of the neck of the tube. It is these two coils are to be used to be rotated. It is mechanically at the same angular velocity of the antenna. So according to the rotation of the angle, okay, it is going to give you the actual display of the target. Okay, so after explaining it is plane position, okay, okay, so that you can able to understand this very, it is very clearly. So how actually it is to be rotated mechanically, and according to the rotation it is going to give you the information about the target there. Okay, and if you take the displacement, it is from, it is left hand side of the CRT is going to correspond to the target, and the extreme right of the, okay, display is going to represent the maximum range of the radar. An example, if you take, this is an a scope display under the deflection. If you take the extreme right hand, okay, is the target, and extreme the left hand is going to represent the range from at this end to at this end here. And in this case, if you take the target range is to be represented by the radial, okay, it is the distance from the center, and what the target azimuth angle is given from the top of the display in the clockwise rotation. It is going to be measured in terms of the angle. Okay, an example means, so according to the available of the angle, it can able to be measured here. Okay, this is about the intensity. It is about the differences between the deflection and the intensity. Understood? Okay, it is to be two coordinate. It is of the one coordinate indicated with the polar, and it is of the rectangular display. It is of the circular display, and it is to be controlled by the. It is transmitted and the echo, and it is to be controlled only by the echo signal, and it is to be applied for the vertical and the horizontal deflection plates, and it is to be applied in the form of the coils. It is coil in the opposite direction, in which it can able to rotate. The antenna itself is going to rotate here, and it is to be display the range on, it is left and it is right side, and in this case it is to be displayed according to the angle of the rotation here. It is called as an azimuth. Understood? This is about the differences between, it is the deflection plates and the intensity modulation. And if you take an example of the deflection modulation, an example of an A-scope display. Okay, again, it is the exactly same explanation. What the deflection modulation technique is used in the A-scope display. It's nothing but it is cathode ray tube indicator. It is the CRO. It is cathode ray oscilloscope itself. And what this is the marking of the range, which are called as of, it is the range markers. And along the x-axis, it is going to measure the distance or the range. Okay, along the x-axis, so that you can able to see this line here, arrow mark. It is going to measure the distance or the range, and along the y-axis it is going to measure the amplitude of the received signal. It is the reflected echo signal. Its amplitude is to be measured along the y-axis, and after that you can able to see the transients here. You can able to see if this is assumed to be, it is the transmitted pulse. Okay, so that its echo is to be obtained after the some time, so that you can able to see this is the permanent echo, and it is the first target achieved, and this is the second target signal, etc., etc. In that way it is to be continued. And it is, what about this one is the ground clutter, or this is the ground noise, all this one. Okay, so in the A-scope display, it is nothing but it is cathode ray tube indicator, and it is to be marked with the range markers, and along the x-axis it is going to measure the distance or the range, and along the y-axis it is going to measure the amplitude of the reflected signal. It's the echo signal, and it is what this hums. It is going to indicate, if you take the first hump is the transmitted pulse, and it is whatever the succeeding is the echo pulses. It can able to measure the range. It is by measuring the time, it is from the transmitted pulse to it is the received echo. It is from at this point to at this point, so that the actual width of the time is to be measured, and according to that it can able to calculate the range here. And the existing disturbance in between is the noise here. Understood? Okay. So that if you take this A-scope display, the A-scope display is similar to that of an ordinary oscilloscope. It is where the horizontal coordinate represents the range, and what is vertical coordinate represents the target echo amplitude. Okay, that's what I said. It is what this horizontal coordinates is going to measure the distance, and what this vertical coordinates is going to measure the amplitude here. Okay, the horizontal coordinate represents the range in terms of the time, and what this vertical coordinate is going to represent the target echo amplitude. And what this transmitted pulse and the echo pulse are applied to the this vertical deflection plates of the CRT, and what this the sawtooth waveforms are applied to the horizontal deflection plates. So it is about the deflection modulation technique means. So it is to so what the signals is to be applied as in this way, and what this width of the CRT corresponds to time. I said that it is going to measure exactly based on the time. It is from the transmitted signal pulse to it is whatever the actual received echo. It is going to measure the time in between. It is based on the time it can able to measure the range. Okay, it is width of the CRT corresponds to the time. What this displacement from the left hand side of the CRT corresponds to the it is target. The extreme right of the display represents the maximum range of the target, so that you can able to see it is two arcs here. You can able to see this is the arc one, which is to be placed at the left side, and you can able to see the another arc at the right side here. This is the place at which it should be initiated, and it is the place at which it is indicating the maximum unambiguous range. So it is whatever the reflected signal. Okay, it is to be received, it is within this line only. And if it can able to receive after this line means, it is to be assumed as of the unambiguous range or unambiguous signal. It is what is the meaning of the unambiguous, I have explained in the previous class. Okay, if the signal has been arrived after the transmission of the second pulse, okay, it is called as of the maximum unambiguous range signal. Okay, so that it should appear it is within this time here. So for that purpose, I am going to read this again. It is width of the CRT correspond to the time. What this displacement from the left hand side of the CRT corresponds to the target. The extreme right of the display represents the maximum range of the radar. It should able to receive the echo. It is within this the maximum range. Okay, and what this flyback it is speed is the rapid, it is beam is the blank during flyback in the absence of the received signal. What the display is horizontal straight line as indicated. The first flip is due to the transmitted pulse wave as the reference, and what this the strong the blips, or it is due to the reflection from the ground, and what this nearby objects height of the each blip it is correspond to the strength of the return echo, and what the distance from the reference blip indicates the range here. Okay, so that it is going to indicate that it is whatever this has been arrived in between is acting as of the as the noise. It has been arrived. It is mainly due to the obstacles existing around the radar. So all this is to be neglected, and it can able to take only the reference from the permanent echo. Okay, this is about the A-scope display. Understood? Again, I am going to repeat you in brief. The A-scope display It is one type of the deflection modulation technique. So it's nothing but the cathode ray tube indicator. It is to be marked with the range markers, and it is what this the horizontal line is going to measure the range, and it is what this vertical it is going to measure the amplitude of the echo. And what this the signal is to be transmitted, it is from the first, okay, left, and afterwards it is going to receive the echo signals according to the available targets, and it should be accepted. It is within the extreme okay, right end. It is the indicating the maximum range. And it is what the transmitted pulse and the what is echo pulse is to be applied for the horizontal plates, and what the sawtooth waveform is to be applied for the reflection, and in I'm sorry, apply for the horizontal plates. And it is whatever the obtained as the noise is mainly due to the obstacles present around the radar, and it is to be get okay neglected, and it is going to measure the range in terms of the time here. Understood? This is about the A scope display. And if you take, it is plane position indicator. It is also called as the PPI. It is plane okay position indicator, and it is also called as of it is P scope, and it is an intensity modulation. Okay, it is mapped like okay circular display. Okay, that gives the target. It is located in the polar coordinate. It is to be represented with the points. It is to be represented with the points here. So an example, you can see the point here, okay, the black dot. So the actual target is available at this point, and its range is to be measured from the center. Okay, it is from the center, it is to be calculated its actual distance, and it is itself is indicating the range here. Okay, so that you can see the another example. So in this it is identified with the number of the targets here. This is the target 1, it is 2, it is 3, okay, 4, okay, 5. It is going to measure the actual distance available from the center. It is based on this, it can able to measure the range here. Okay, and it can also, so instead of considering the end, so entire 360-degree, it can also able to measure the range only for the certain angle also. It is called as of the sector PPI. It can able to identify the target if it is available. It is within the what in this azimuth angle, and if it is above this angle means whatever the target is available above this angle is unidentified. This is about it is P scope display. Okay, so a plane position indicator is a type of the radar display, okay, that represents the radar antenna in the center of the display, so that you should assume the antenna is available exactly at the center. It is from the center, the actual distance is to be measured. So you should assume the antenna is available exactly at the center here. So it represents the radar antenna in the center of the display, and what the target range is represented by the radial distance from the center, and what the target azimuth angle is given from the top of the display in the clockwise rotation at the north side. It is to be rotated in the clockwise rotation, from at this point. This is going to be the 0 degree, and it is going to be rotated in this direction. It is going to take the 90 degree, again it is going to be rotated, it is 180 degree, etc, etc. In this way it is going to form the rotation here in the clockwise rotation. And what this scanning away from is applied, it is two pair of the coils on the opposite sides of the neck of the tube. I said it is while explaining the intensity modulation. Okay, what it is, these two coils are to be it is to be rotated mechanically at the same angular the velocity of the antenna, and it is hence the beam is to be deflected, okay, rapidly outwards from the center and the back rapidly. It is depending upon the rotation of that Okay, it is going to give you the availability of the target within the azimuth angle. Okay, and what the brightness of any point on the screen indicate the presence of an object. If you see anything to be get in the intensity or in the brightness, it is itself is acting as the target. You can able to see here. It is represented with the white. Okay, it is the white here. Okay, indication of the target here. Okay, so the brightness of any point on the screen indicate the presence of an object, and what the position of the bright spot is going to correspond to the actual physical position of the object. Its range is measured, okay, radially out from the center. It is to be measured from the center. It is what I said. And what the long this persistent this phosphor screen is used for the display of this PPI, and what this PPI screen is to be circular, and what this their diameter is the maximum up to the 40 centimeter in size. This is about the PPI. I think you have understood. So the simple point to be remembered is, in case of the A scope, it is going to give you in terms of the signals here. It is like the waveforms. But in case of the PPI, it is going to give you in terms of the dots here, the availability of the target here. Okay, this is about the radar, okay, display system. Okay, so I think in this class I have explained about it is what we mean by it is a radar display system, and it is what are the techniques. It is one is the deflection and another one is the intensity. And here what we mean by the deflection, it is going to make use of the two coordinates. It is one is along the x-axis and another one is along the it is y-axis. And intensity, it is going to make use of only the single, it is polar coordinates. And what is the difference between the deflection and the intensity is also studied, and what the A-scope display pattern is also studied, and what is the pattern of the PPI position indicator is also studied. Okay, and if you take the possible questions, so as per this concept is, so that he may ask you to write the short notes on this the radar display system, or he may ask you to give the comparison between this deflection modulation and the intensity modulation, or he may ask you to write it is with a neat diagram explain the A scope display, or with a neat diagram he may ask you to explain this P scope display or it is PPI indicator. So he may also ask you to explain the differences between it is P scope and this PPI. Again, it's nothing but the differences between the deflection and the intensity. Understood? So it is all about the radar display, and in the next class we are going to study about the antenna scanning and okay tracking. Okay. Okay. Thank you very much.